Hey, what's up, mathletes? It's Mr. Noldy here, your personal math coach. Stick around because we're going to be talking about transformations. A transformation is an operation that changes the graph of an equation. The original graph that we call the pre-image is transformed into something that we call the image. So the type of transformation that we're going to talk about today is called a translation. So that means we're going to shift a graph horizontally or vertically, up and down the y-axis like this, or we may shift it, horizontally, left and right like this. Or we may do a right shift and then up. You could go left and then up. So these are just some basic, what we call translations. The shape of the image does not change at all. In fact, it's just being moved around. So up, down, left, right. It could also be flipped as well. The other thing that we can do is we can reflect it across the x-axis, across the y-axis this way. So it would end up looking something like this, and I haven't figured out how to flip it yet, but it would come something like this. So, without further ado, let's get to how we transform some of these functions. So whenever we do this, let me get my pointer on, add or subtract a number from a parent function. In this case, it's x squared. This is going to tell us to move our graph up or down this number of units. So for instance, with x squared, here is my parent function. Looks something like this. It's not perfect, but it gives you the idea. So if I were to graph this yellow function right here, I'm going to take this red function, I'm going to move it down 3 units, down the number line, the y number line. So here's how it would end up looking. I could draw 3, I suppose. 1, 2, 3. But again, this graph does not change its shape. It only changes its location. So this is what we call a vertical transformation, or translation rather. It's a transformation, but a translation is a more specific term than a transformation. Translation means you're just moving the image, the pre-image, and it doesn't change its shape at all. Now let's look at a horizontal shift, moving an image, a pre-image, left or right to make a new image. So I'm going to take this parent function, y equals x squared, and I'm going to turn it into this function written in red, x minus 3, the quantity squared. So notice it's not x squared minus 3 out here. So the minus 3 is in a different place. It's inside the parentheses. So that's telling me that I'm going to move this left or right. And it's counterintuitive, but the minus means I will be moving it to the right. So what I would do, if I was just doing a quick sketch here, is I would count 3 units to the right, and I would have the exact same image. Not the best drawing in the world, but you get the idea. So the image does not change at all. I'm not stretching it or shrinking it or doing anything to it. I'm just translating it 3 units to the right. So the last type we'll look at, last type of translation, is a reflection. So the image itself is not changed, but it is flipped or reflected across either the x-axis or the y-axis. What causes the flip is where we put the minus sign. So suppose I have y equals the opposite of the square root of x, right? So the red function is my parent function. y equals the square root of x, graphs like this, and the minus on the outside is flipping the y value, so it's going to flip across the y-axis. So it's going to look like this. If I was a good artist, this would look like an exact replica across the x-axis. The yellow would be of the red. The other type of reflection that we can do is we can flip it across the y-axis. So in order to do that, we don't change the sign of the y, we actually change the sign of the x. So I'm going green, and instead of putting a minus sign on the outside like I did up here, we're going to put a minus sign on the inside. So negative x. So when the negative sign is on the x as opposed to on the function, it is telling me to flip this across the y-axis. So I'll draw that in green just to match it up. So it would look something like this. Now also keep in mind we can combine a lot of these, so that's what I'll show you in a second. So here's kind of a combination of all three of those things. We're going to do a flip or a reflection. We're also going to slide it left and right, and we're going to move it up and down. So for good measure, I used another parent function because we should know what all these are. This is y equals the absolute value of x. So it graphs like this. So what we're going to do is we're going to create a new function. We're going to take this vertex point right here, and let's see, we're working from the inside out. This is inside the symbols of inclusion. These aren't parentheses, they're absolute value symbols, but we would still move this 2 units to the left. So 1, 2. Then we would flip it. So we're going to reflect it. This is on the outside, not the inside, the outside. So it's going to get flipped across the x-axis. And the last thing that happens to it is we're going to move it down 1 unit. So let's do this. We'll start here. We're going to go 2 units to the right. Let me draw those 2 units in. So we're going to go 2 units to the right over to here. It's going to flip, which I'm not going to see that just yet. It's going to go this way. But after it flips, it's going to go down 1 unit because of this -1. So I'm going to go down 1 unit. So my vertex ends up being right here at -2, -1, and it's the exact same function. There's been no shrinking or stretching of it. It is the exact same spitting image. It's just that it's been moved around, reflected, and things like that. So that was kind of my point here with the basic transformations. All we did was translations. We didn't change the shape of any of these figures. So thank you for watching that to the end. These do get a little bit confusing sometimes, but I promise you that the more you look at them, the better you'll get at them. Remember, math is not a spectator sport. It's something you have to do to get better at. So go ahead, hit the like button, and I'll catch you on the next one.